Hi, and welcome to Section 3, Working with Data in Julia. Before we are able to process data, we need to get them out of their data sources and into our Julia program. In this section, we will learn how to work in Julia with data from various data sources, such as structured files, relational and NoSQL databases. We'll use data arrays and data frames to store the data within Julia. Now, we move on to the first video of this section that deals with reading and writing data files and Julia data. After this video, you can extract data from all kinds of data files into Julia for further processing. More specifically, we are going to take a look at CSV, HDF5 and JSON files. Furthermore, we'll learn the built-in way to store Julia data to disk with JLD. Already in video 1.6, we applied the basic code for reading and processing a file line by line. The do-file syntax automatically closes the file when finished, so it is better to use this form. Writing to a file is just as easy, as shown in this code snippet, where we have defined a type iris, made an instance iris1 of that type, and written this information to the file example.dat. To append to a file, use the A option instead of W in Open. The file iris.csv contains the same iris data as before, but now the fields in each line are separated by a comma. We can read its data into an array with the readCSV method as shown here. Data is now a matrix with 150 rows and 5 columns, all of type any because no common type could be found. The same result can be obtained with the readDLM method, where you can give the delimiter character as the second parameter. This method is much more versatile, as you see in the second example. The data type can be given the line separator, whether or not there is a header line, with the column names, which are the metadata, and so on. To write to a delimited file, we use the writeCSV method, or more general, the writeDLM method as shown here. Julia also has a CSV package specifically aimed for working with CSV files using the Data Streams interface. I hope you found this easy. Perhaps you have already come across HDF5, which stands for Hierarchical Data Format version 5. It is widely used as a portable scientific data format. It is structured like a file system and has two levels: datasets, which are multi-dimensional arrays of the same type. They have the extension .h5. Groups, which are container structures and can hold datasets and other groups. If HDF5 is new to you, here is a link where you can find more information on where it can be used. To start using HDF5 data from Julia, we need to install and import the HDF5 package. This won't be an issue, so moving ahead. The following code shows how you can write to a plain H5 file containing no groups, and read from HDF5 format. We use the same iris1 value and store it with the string iris1 as a dataset name. I listed the different possible options on the screen. A group named iris can be created as shown in this screen with g_create. Then we create a dataset with the name dset1 inside this group and give it the value 150, and we also give the group a description attribute. To read this info back, open the file. With the group name as an index in the file, you can retrieve the group data. Then a data set can be read from the group with read. Isn't it pretty straightforward? The dump command on an HDF5 file descriptor gives you a simple overview of the contents. More info can be found in the package documentation here. Let's take a look at the native twin of Julia, JLD, Julia has its own built-in way for storing objects in files, with the extension .jld. This is accomplished with the JLD package, which stands for Julia Data. It is in fact a dialect of HDF5, so the commands are very similar. The advantage over HDF5 is that the Julia type of the data is preserved, even the types you defined yourself. Let's see how it works. You give a variable a storage name, species in our code, and then you save it to a JLD file. Whenever you need that data back, you load the file. As we can see, from the return value, all variables are saved in a dictionary with the storage name as a key. So, you can save multiple variables or a complete dictionary. When you don't supply variables, the entire Julia workspace is stored. The same functional syntax using do with read and write can also be used for JLD. If we additionally import HDF5, we can also save in the same group and dataset structure as with HDF5. Julia has a package JSON to parse JSON data files. We have stored some data in iris.json. Here is an example of processing a JSON file. We read in the fill with read all. After some cleanup, we loop through the data, and each record is converted to a dictionary using json.parse. The other way around, the json.json method can convert any dict, like D in the example, into a JSON string. We'll continue to work with the complete iris dataset in JSON format in video 3.5, where we import it in MongoDB. To finish, here is a useful command to download a data file from any URL. Simply supply the URL and optionally a name for the file on your system, like this. In this video, we learned how to extract data from delimited tabular files like CSV. We got to work with the HDF5 format and its native Julia twin, JLD. Finally, we also worked with JSON files.